Welcome back, YouTube. This is Welcome Back Tuesday, the first day of school after summer, and we did our book cards and seating assignments and whatnot. So now let's do a quick introduction to Sage. Sage is a computer algebra system. It does, it does scientific calculator stuff and graphing calculator stuff, and does your algebra for you and the calculus for you and all that kind of stuff. It's good to check your work. And it gives you answers in simplest form. So it's a nice alternative to a calculator, and you can use it on a tablet, on a phone, on a laptop, whenever you're on the internet. I think Sage is now on cocalc.com, is actually on the Google Compute platform, so it's really in the cloud. So we're computing in the cloud. So go to cocalc.com. If you don't have an account yet, it's very easy. Just log in with your Gmail account. Just going to ask you for your name and your Gmail address, and that's about it. And so now let's create a project. The project is sort of like a folder, okay? So I'm going to call this project Pre-Calculus 2017-2018. Yay! Create project. And there it is. All right, let's open the project. Well, we're in. All right, now let's create a file. Okay, so this is going to be 1200. I'm starting with chapter 12, and usually we start with chapter 12, section 1. I'm just making this up, an extra section 0. Intro to Sage. There you go. And let's create. Now I think it defaults to Sage, to a Sage worksheet. So I'm just going to hit create. What happened? It's still loading. All right, hang on. Wake up. My Wi-Fi is a little slow. Project runs on free server. Yeah, we know that. It's going to be a little slow in the free server, but there you go. Yes, hello. What just happened? No files found. I thought I just created... Alright, yeah, X that out. Go away. Let's try that again. 1200. Screencast 12, section 1200. Intro to Sage. Okay, there you go. Right, and it's defaulting to a Sage worksheet, so I'm just going to create, or you could just click here. I think I just create. I'm good. There I am. Okay, loading. It's a little slow today. Guess a lot of schools are on here now. There you go. Alrighty, so let me make a note to self. Let's just do, let's start real easy. Sage is based on a programming language called Python, and Python is based on 7 arithmetic operators. Okay, so let's write this. The 7 arithmetic operators. All right, that's note to self. That little hashtag, that's just a note to self. Humans talking to humans. Okay, and then let me write some code. Now, all right, what are the operators? How about addition? All right, so let's show 2 plus 7. Just basic arithmetic today, nothing fancy, and click run, like the play button, and you get stuff. Wow, this is really slow today. Come on, today. Must be my Wi-Fi at school here. Come on. Well, can you guess in all the time you've got here to figure this out? 2 plus 7 should be 9. There it is, 9. Good. Alrighty. Let me continue on the same, go to the end of the same line, hit enter. Let's do show 2 minus 7. All right, guess. Can you guess? -5? Yes, there it is. All right. How about show 2 times 7? Let's try that. That's 3 arithmetic operators. What else? Dividing, right? Okay. Let's show 2 divided by 7. And hit run. Used to be able to do Control-Enter. I don't know if you can do that. And look at that answer, 2/7. Really? I know 2 divided by 7 is 2/7. It's a rational number, an integer over an integer, right? But that means as a decimal, it should be a repeating decimal or a terminating decimal. Actually, they're all repeating decimals, right? Because like if you say 1/2 is 0.5 is terminating, you can think of it as 0.5000000 forever, so it's really repeating. So any rational number can be expressed as a repeating decimal or the ratio of 2 integers, right? So there you go. And let's numberify that. This is not a word, English teachers, sorry. So put the calculation in parentheses, .n. There you go. That's an n function built into Sage to convert this to a decimal, okay? So run. And, oh, I didn't close my parentheses for the show. Okay. Can I make this a little bigger? Whoa, that's way too big. There you go. Okay, make it a little bigger. And run it. And you get, there you go. Now notice 2/7 is a special repeating decimal in that it repeats, I can't highlight stuff here? Oh, wow. Okay. It repeats 285714, 285714, right? Just like 1/7 is a repeating decimal. You know repeating decimals, 1/3 is 0.3333, 1/9 is 0.1111, right? So, is that enough to see that it's really repeating? Yeah, maybe not. How about we throw in some more digits? Digits equal 100. And run that. And today, there you go. And so this is being calculated in real time. All right, this is not stored anywhere. Sage is working on the Google Compute platform doing this stuff for you. If 100 is enough, you could do 1,000, you could do 10,000, 100,000, whatever you want. And there you go. Oh, I can see it here. See, you can slide this. No, where's the slide? I just saw it. Where'd it go? There it is. So is it going to let me slide? It won't let me slide. Anyway, there it is. And you can see all of that. I think if you do a print, you could probably get all the digits to fit on one screen. But there you go. Well, let's not get nuts. Let's just do 100. This is just a quick summary of what we did in class. And there's your 100 digits of 2/7 as a decimal, right? Okay, so I said there were 7 operators. Give me another one. Add, subtract, multiply, divide, exponentiate, right? Oh, okay. How about this? Show 2 to the 7th. Notice the symbol for exponentiation in Python, the Python programming language. It's like multiply, multiply. It's like a lot of multiplying, right? Isn't that what you're doing in exponentiate? Okay, so run that. And you get 128, right? There you go. Okay, how about to the 77? Haha. There you go. How about to the 777? This is being calculated in real time for you. The only slow part of this is my Ethernet connection. Look at that huge number. Look at that. That's one integer. All these digits are in front of the decimal point. Now, it's hard to see all of that. It goes off the screen. What if I did a print? Print. Will that make a difference? That used to make a difference. So it should fit on the screen. And there it is. That's the whole thing. Well, there's that other stuff. But there's the answer after the 0.2857. That's the 2/7, this line, right? And I think that's pretty much, I think that's it. That's the whole thing. Okay? You can't see it because I magnified the screen. But there it is. Okay, so let me just make it bigger here so you can see what I'm doing. There you go. And you can go nuts. How about to the 777? Aha! Okay, I'm not going to ask you to name that number, but I'm going to ask you to estimate how many digits do you think are in that integer. This is just one integer, no decimal part, right? This whole thing is one integer. Look at that crazy thing. How long do you think that is? Well, what I'm going to do is I'm going to turn that into a string, and I'm going to show that. And let's run it. And you get the same thing, but now it's a string, which means we're pretending that these digits are really characters in a word. There's one big long word where I can measure the length of the string. So len of the string of that. So guess, how many digits do you think that is? We're going to find out right now. Here we go. And 2,342 digits. Okay, very good. Now, didn't I say there were 7 operators? Add, subtract, multiply, divide, and exponentiate. What else? Well, wait, there's 3 kinds of divide. There's a divide that gives you decimals like we did there. Let me sneak this in here. How about we show 2/7? What does that do? All right, so after the 2/7, before the 2348, 42, what are we going to get? A new result? And it's going to be 0. 2/7 is 0? Really? What does that mean? And how about this? Show 2%7? Whoops, %7? What does that mean? Let's try that. So after the 0 we get 2. Maybe it would be more obvious if I do it the other way around. How about 7 / 2 and 7% 2? So these are 3 different kinds of divide. So what does the / do? Let's see. 2 into 7 goes 3 times evenly with the 1 remainder. So this is how many times it goes in, and that's the remainder. We call this div and mod, or the modulus. Okay, what the remainder when you divide by 2. When you do integer division, when you first did long division way back when, 3rd grade, whatever, and you had remainders, that's what we're talking about here. Okay. Let's see now. So that's the arithmetic part. Okay. You can do algebra. How about algebraic operations? Hey, okay, so just for fun, all right, let's see, I'll go down here, and I'll do comment, algebraic operations. All right, so how about this? What if I let f of x equal, what would I like? X squared plus 2x plus 1. X squared, by the way, you don't have to do star. They added the caret symbol because a lot of people coming to Sage from the graphing calculators where you use TI Basic, which uses the caret instead, so they threw that in. It's not really Pythonic, but that's okay. Plus, what did I want? 2x plus 1. Okay, plus 2x times 1. Be careful, the multiplication is not implicit. You cannot say just 2x. You have to say 2 times x if you mean multiplication. Plus 1. Let's say that's f of x, right? Now if I show f of x, you get, there you go. That's it. All right, good. Now, whoops. What if I show the factoring of f of x? Aha, show factor f of x. Let's factor f of x. And there it is. So this is the factor. It's x plus 1 times x plus 1, isn't it? Or what if you want to FOIL it out? What if you say show, let's see, x plus 1 times x plus 1. Let's see. And you get, well, the same thing, but okay, so you can force it. You can say, okay, expand. So put in parentheses what you're trying to FOIL out or distribute out and do dot expand. Alrighty. Come on. Oops, what happened? I keep on forgetting to close the show, sorry. And there it is. So it expanded it, right? Okay, so you can add, subtract, multiply, divide, whatever. Dividing means factoring, right? Polynomials and stuff like that. You can graph them. What if I say plot f of x? Let's say. And there it is. Now, f of x, since it factors as x plus 1 squared, if you set that equal to 0, whoops, where'd it go? There it is. If you set that equal to 0, x plus 1 equals 0 when x equals -1, so there's a 0 at -1. And there's only one 0 because it's a repeated root, right? So both factors are the same, so it shouldn't cross the x-axis at -1, right? So that's just a repeated root where the graph bounces off the axis. How do you see that? Well, change the domain. It's defaulting to x min is -1 and x max is +1, and then y min, y max is calculated. You could change the x min, just state it. How about -2, and then x max, how about +2? And let's hit run. And the graph now goes from x equals -2 to x equals +2 and so forth. And you know, you could do all kinds of crazy stuff with this. How about let me think. How about solving? What if I want to solve something? All right, let's do it here. What if I show, by the way, if you don't write show every time, it won't keep the output for every line. It'll only keep the output if you have a show or the very last thing you did. So if you're only interested in the very last calculation, you don't have to write show all the time. But you could write print or show. Show gives you sort of like pretty print, like in textbooks, you know, like LaTeX output. How about if I show solve when is f of x equal to 0? Now be careful, it's equals 0 because equals is a Boolean that's either true or false. And the solve command, you have to say what you're solving for. I'm solving for x. Is trying to make that statement true. So before the graph, I should find that x equals -1. Let's see. There's got to be a better way to run this without clicking this up here all the time. And. Come on. Why is it giving me 2 graphs? Well, x equals -1 is the answer, right? And did I ask for 2 graphs? What happened there? No? That's really odd. Alright, well, let's leave it at that for now. It was just supposed to be a quick introduction. So, does this save automatically? I think so. We're just going to click save and make sure it's done. Alright, so that was our quick introduction to Sage. Just a little arithmetic and algebra and graphing, and sort of like what you can do on a graphing calculator. So whenever you want to use a graphing calculator, you can use Sage instead, but there's a lot more you can do, and we'll try and show you what that is as we progress throughout the year. Alright, so I hope that was helpful. Don't forget to make your own cooperative calculating account, cocalc.com, and see you next time. Okay, bye-bye, YouTube. Hope that was helpful. Thank you. Bye-bye.